All right, good morning. Welcome back to Elements Calculus 2. We are continuing talking about the pretest here, and I've got next problem number 2 sitting up here. So this one is a little bit on the tricky side. Let me tell you that right now. You will see a problem like this on the test, not exactly this one, but it's something like it. Now, it's possible to do this one by integration by parts, but it is a little bit a long way around. So we're going to do it with regular U substitution. The way you do that is usually you have some kind of a linear term, linear function inside of a radical or outside of a radical with some kind of a radical with something bigger. Okay, so that's usually how you do this. Like we've got some kind of a weird radical, weird square root, cube root, whatever, and there's a linear function inside of it, ax plus b, okay, or mx plus b, however you want to do that. So we're going to go ahead and start our substitutions. We're going to say let u equals what's in the radical. That's the thing that's a pain, x plus 4. And now, when you try to start figuring out what's going on here, you kind of run into a dead end real fast because you get like, okay, we've got x squared times the square root of u. That doesn't look like it helped. By the way, anytime you take a substitution in calculus, you immediately figure out its derivative so that we can go ahead and replace the dx with whatever we have. Okay, and this doesn't seem to be going anywhere, but there is a thing we can do because just because we have x equals u plus 4 doesn't mean that u minus 4 could equal x. Because you're allowed to do that. You can back substitute that way. So since u minus 4 is equal to x, what we're going to do is we're going to say this is u minus 4 squared times, I'm going to call it u to the 1/2 power du, and that's what we're going to try to integrate. Now, again, we don't want to do integration by parts on this. We just want to see, well, this is kind of not the best or the funnest way to do this, but we can just get this problem done and say u squared minus 4u plus 4 times u to the 1/2. We're still going to integrate here. U. From here, now we can distribute this u to the 1/2. So what's going to happen is we haven't done a calculus part yet. So this is going to be, remember, when the bases are the same, we add the exponent. So 2 plus 1/2, we have 2.5, or 5/2. Okay, minus 4. The bases are the same. It's u to the 1. 1 plus 1/2, we get u to the 3/2, plus 4u to the 1/2 du. Now we'll go ahead and integrate this thing. Again, add 1 to each of the exponents. So we have u to the 7/2 times 2/7 minus 4 u to the 5/2, we added 1, times 2/5 plus 4 u to the 1/2, and we're just going to add 1, 3/2 rather, times 2/3, don't forget, plus c. Let's clean this up a little bit so it looks a little bit nicer. And the original problem was given to us in what variable? U. So we're going to go back to say this is x plus 4 raised to the 7/2 power. You don't have to do anything more to it than that. This is a minus 4 times 2/2 is going to be 8/5 rather, not halves, fifths. X plus 4 raised to the 5/2 plus 8/3. X plus 4 raised to the 3/2 plus c. That looks delightful. So that is our problem solved for this thing. Be careful with these problems. Anytime you have a linear function, an x to an n power times the square root of an mx plus b, or vice versa, that's usually a good hint for you to do this kind of a problem. Okay, that's the style you're looking for. That's what we did. Okay, so these are a little bit tricky. There will be one on your exam. So thank you very much for watching. I will see you in the next video. Pause.